Scene 1. The setup. Mass versus volume. Let's define the rules. Earth keeps its mass, 5.97 or 1024 kilograms, but its diameter shrinks from 12,742 kilometers to 1 centimeter. A planet compressed into the size of a marble, denser than any known object short of a singularity. This isn't just theoretical, it's a recipe for disaster. Scene 2. Gravity intensifies beyond belief. Gravity depends on mass and distance. Shrink the radius, and gravity at the surface skyrockets. Standing on this marble Earth, you'd be crushed instantly, pulled inward with the force of 1029 times Earth's gravity. Even light can't escape this pull anymore. That's right, Earth would instantly become a black hole. Scene 3. Wait, isn't this just another black hole? Yes. In fact, this is how black holes are formed. If you compress Earth below its Schwarzschild radius, about 9 mm, it becomes a singularity. So this isn't just a dense planet, it's the death of planetary physics. Space curves, time warps, everything nearby gets sucked in. Earth, as a marble, becomes a gravitational monster. Scene 4. What happens to the Moon and orbiting satellites? The Moon would continue to orbit the marble Earth for a while, as long as the mass stays the same. But any satellite passing too close would be torn apart by gravitational tidal forces. Eventually, the Moon might drift closer and cross the event horizon, vanishing forever. The same goes for anything else. Debris, asteroids, even spacecraft that wander too near. Earth becomes a trap in space. Scene 5. Visual distortions and time dilation. To a distant observer, Earth's marble-sized black hole would be nearly invisible, except for the light-warping lens it creates. Starlight behind it bends, creating rings of distorted space. But near it, time slows. Seconds stretch. Gravity redshifts light into deep infrared. If you hovered just outside the event horizon, you'd see the future unfold, while barely aging yourself. Earth, once a home, is now a clockwork prison of time. Scene 6. Could anything survive nearby? Survival would be unlikely. Temperatures around the black hole might be near absolute zero, unless there's accretion matter heating the surroundings. But even then, radiation bursts from infalling material could fry anything unshielded. Maybe spacefarers, alien or human, might place stations in stable orbits, using the black hole for science, energy, or propulsion. Or perhaps AI minds float nearby, studying this strange relic of a once-living world. Scene 7. Why this matters in real physics. This thought experiment isn't just fantasy. It teaches us about the limits of matter, how space, time, gravity, and mass interact at cosmic extremes. It echoes real dangers, like black hole formation, neutron stars, and the collapse of superdense materials. And it reminds us, scale matters. Not just what a planet is made of, but how much space it takes up. Scene 8. From marble to mystery. Imagine an alien species discovering a black hole the size of a marble. They scan it, study its mass, decode its structure, and discover it once was a planet, with oceans, civilizations, music, art, a place where children once played, trees once swayed, and clouds once danced in the sky, all now compressed into a perfect sphere of silence. Earth, not forgotten, but transformed. Outro, somber piano melody. Camera pulls back from the black sphere floating among stars. So what if Earth was shrunk to the size of a marble? It would vanish, not in light, but in gravity, leaving behind a mystery, a distortion, a wound in space where a world once was.